guys, it's me, Afraz, the Knowledge Man, and today we're going to be starting exercise 1.1. It's going to be a 3-part series, so stay tuned. Today we're going to be doing question number 1, and we're going to be doing the other parts in other videos. So let's get right into the first part of the first question.
In question number 1, we have 6 parts, and we have 6 hidden quadratic equations, which we have to write in standard form. Let's start off with the first part. Part 1 is x plus 7 into x minus 3 is equal to negative 7. So let's multiply x plus 7 and x minus 3. X into x is x squared. X into negative 3 is negative 3x. 7 into x is 7x. And 7 into negative 3 is negative 21. Let's write that all down. We get x squared minus 3x plus 7x minus 21 is equal to negative 7. So, simplifying the two of these, we get x squared plus 4x minus 21 is equal to negative 7. Let's send negative 7 to the other side. We get x squared plus 4x minus 21 plus 7, which is equal to 0. Because there's nothing on the right-hand side anymore. So we get x squared plus 4x minus 14 is equal to 0. As we can see, this is indeed a quadratic equation in standard form, as this is in the form ax squared plus bx plus c is equal to 0, and a is certainly not equal to 0. So this is a quadratic equation in standard form. But it also asked us whether to prove whether or not, not to prove. It asked us whether or not they're pure quadratic equations. Do you remember the rule that we discussed for a quadratic equation to be a pure quadratic equation? We said that for a quadratic equation to be termed pure, b must be equal to 0. But over here, b is equal to 4, because we have 4x right here. So for this reason, this is not a pure quadratic equation. Let's move on to part 2. Part 2 is x squared plus 4 divided by 3 minus x divided by 7 is equal to 1. Okay. For this problem, we have denominators, and we don't want denominators because it just makes our job more hard and it makes the question more complex. So let's find the LCM. LCM is just the product of the denominator, so that's 3 multiplied by 7, which is 21. So now we're going to multiply all terms by this LCM. So x squared plus 4, 21, divided by 3, minus 21 into x, divided by 7. So right here, we can simply cut 3 and 21 and we get 7. So right here, we can simply cut 3 and 21 and we get 7. And 7 and 21 and we get 3. But usually, if we have some variables in the denominator such as x plus 3 and x plus 2, it's better not to multiply them like we did right here. It's better to just leave them alone. And so it's better to leave them alone. And yeah, you can simply cut. Because it's just like extra work. Anyway, so we get 7 into x, is equal to 21 multiplied by 1. So we get 7 into x squared plus 4 minus 3 into x is equal to 21. So 7 into x squared is 7x squared, 7 into 4 is 28, and 3 into x is 3x, and there's a negative sign right here, so we're going to multiply that, and we get negative 3x. So we get 7x squared plus 28 minus 3x is equal to 21. So let's rearrange this. We get 7x squared minus 3x plus 28 is equal to 21. Sending 21 to the left-hand side, we get 7x squared minus 3x plus 28 minus 21 is equal to 0. So 7x squared minus 3x plus 7 is equal to 0. And yeah, so is equal to, and we're done here too. This is a standard quadratic equation. A quadratic equation standard form. Because it's in the form ax squared plus bx plus c. And a is not 0. But it's not pure because b is equal to negative 3. And b is not equal to 0. Part 3. Part 3 is x divided by x plus 1 plus x plus 1 divided by x is equal to 6. So let's take the LCM. LCM is going to be x into x plus 1. And so x into x plus 1 divided by x plus 1. So here, as we can see, these two can simply cross out, and it's not really as complicated as having to multiply this, and then we get x squared plus x, and then we unsimplify it. It's just straight up plus x into x plus 1 into x plus 1 divided by x. So x and x cut out is equal to 6 into x plus 1. So we get x squared plus x plus 1 whole squared is equal to 6 into x squared plus x. So x squared plus, opening this square, we get x squared plus 2x plus 1 is equal to, here, 6 into x squared is 6x squared, and 6 into x is 6x, so 6x squared plus 6x. So 2x squared plus 2x plus 1 is equal to 6x squared plus 6x. Now we see that on the right hand side, the coefficients of x squared and x are greater and they're positive. So we're going to send all the terms from the left hand side to the right hand side. But I'm going to be writing it on the left hand side. So 6x squared plus 6x minus 2x squared plus 2x, oh oops, it's not plus, it's minus 2x minus 1 is equal to 0. So 4x squared plus 4x minus 1 is equal to 0. And that is it. So here we have it in the form ax squared plus bx plus c is equal to 0. But a is not 0, but b isn't either. So since b isn't either, it's not a pure quadratic equation. Okay, so let's move on to part 4. Part 4 is x plus 4 divided by x minus 2 minus x minus 2 divided by x plus 4 is equal to 0. Let's find the LCM. LCM is x into x minus 2. So let's multiply all terms by x into x minus 2. So x into x minus 2 into x plus 4 divided by x minus 2 minus x minus 2 into x minus 2 divided by x only, okay, plus 4 into x minus 2 is equal to 0. So this x and this x cut out, this x minus 2 and this x minus 2 cut out, and so x into x is x squared, x into 4 is 4x, and here multiplying these two we get x minus 2 whole squared. So x squared plus 4x minus x minus 2 whole squared, which would be x squared minus 4x plus 4 plus 4 into x is x squared, and x into negative 2 is negative 2x. So we get x squared minus 2x is equal to 0. So we get x squared plus 4x minus x squared plus 4x minus 4 plus, here 4 into x squared is 4x squared, and 4 into negative 2x is negative 8x. So we get plus 4x squared minus 8x is equal to 0. So this x squared and this x squared cross out. So this x squared and this x squared cross out, and this 8x and these two positive 4x's cross out, and we get 4x squared minus 4 is equal to 0. So here, this is actually a pure quadratic equation because the b's crossed out. So b is equal to 0 in other words. So this is our first pure quadratic equation. because it's in the form ax squared plus c. Okay, let's move on to part 5. Part 5 is x plus 3 divided by x plus 4 minus x minus 5 divided by x is equal to 1. So let's find the LCM again. The LCM is x plus 4 into x. So x plus 4 into x plus 3 divided by x plus 4 minus x into x plus 4 into x minus 5 divided by x. So here x plus 4 and x plus 4 cut out. Here x and x cut out. And is equal to 1 into x plus 4. So x into x is x squared, and x into 3 is 3x. X into x is x squared. X into negative 5x is I just messed up. X into negative 5 is negative 5x. 4 into x is 4x, and 4 into negative 5 is negative 20. Let's write that all down. We get x squared plus 3x minus, in bracket, x squared minus 5x plus 4x minus 20 is equal to x into x squared plus x into 4 is going to be 4x. So x squared plus 4x squared plus 4x. So here x squared plus 3x minus x squared plus 5x minus 4x minus 20 is equal to x squared plus 4 plus 4x. So this x squared and this x squared cut out, and simplifying these two we get x, and then adding 3x we get 4x. Terrible line. 4x minus 20 is equal to x squared plus 4x is what we get. And then since x squared is positive, on the right hand side we're going to send 4x minus 20 to the right hand side. So we will... Wait guys, this is supposed to be positive. I'm so sorry. It's supposed to be positive. Anyway. So sending 4x plus 20 to the right hand side, we get x squared plus 4x minus 4x minus 20 is equal to 0. This 4x and this 4x cut out, and we get x squared minus 20 is equal to 0. Once again, we have a pure quadratic equation because we have no b, or in other words, b is equal to 0. So yeah, and it's also in the form ax squared plus c is equal to 0. And actually, it has to be. Okay, so part 6. Part 6 is x plus 1 divided by x plus 2 plus x plus 2 divided by x plus 3 is equal to 25 divided by 12. So let's take the LCM first of all. LCM. The LCM is x plus 2 into x plus 3 into 12. So let's multiply all terms by this. X plus 1 into x plus 2 into x plus 3. Let's just do 12 right here. Yeah, that is a good idea. Into 12. All divided by x plus 2 plus x plus 2 into x plus 2 into x plus 3 into 12 divided by x plus 3 is equal to 25 into x plus 2 into x plus 3 into 12 divided by 12. Okay, so x plus 2 and x plus 2 cut out, x plus 3 and x plus 3, and this 12 and that 12. So we're left with x plus 1 into x plus 3 is x squared plus 4x plus 3, and it's still being multiplied by 12, plus x plus 2 whole squared here. It's going to be x squared plus, oh wait, no. It's going to be x squared plus 4x plus 4, and 12 right here, is equal to 25 into x plus 2 into x plus 3 is going to be x squared plus 5x plus 6. Okay, so 12 into x squared is 12x squared. 12 into 4x is 48x, and 12 into 3 is 36. 12 into x squared is 12x squared. 12 into 4x is 48x, and 12 into 4 is 48. 25 into x squared is 25x squared. 25 into 5x is 125x, and 25 into 6 is 150. So let's write that all down. 12x squared plus 48x plus 36 plus 12x squared plus 48x plus 48 is equal to 25x squared plus 125x plus 150. Since we see that 25 is much greater, or actually it's just greater, just slightly greater than 12 plus 12, which is 24x squared, we're going to send all these terms on the left-hand side to the right-hand side. Oops. So first of all, let's actually simplify. So we're going to get 24x squared plus 96x plus 84 is equal to 25x squared plus 125x 125x plus 150. So we're going to send these terms to the right-hand side. So 25x squared minus 24x squared plus 125x minus 96x plus 150 minus 84 is equal to 0. So we get x squared plus x squared plus 29x plus 66 is equal to 0. So this is not a pure quadratic equation. And this is because b is equal to 29 and 29 isn't equal to 0. But we don't have to make sure that it's a pure quadratic equation. We just have to tell whether it was or wasn't, and it wasn't. So, yeah. See you in the next vid. Peace.